Hi, today I am going to discuss about data communication and networking. Over here you can see the network model, which is divided into two parts, protocols and standards. And consists of protocols and standards. The first part is data communication, consisting of components, data representation and data flow. In the networking part we have internet, which consists of LANs and WANs, distribution, processing, criteria and structure. In the introduction chapter we have got data communication, networking, protocols and standards. In the chapter second we have got network model. In the chapter 1 we have got data communication, network, the internet and the protocols and standards. Data communication consists of components, data representation and direction of data flow. Here telecommunication means communication at a distance. Data, as you know, information presented in whatever form is agreed upon by the parties creating and using the data. Data communications are exchange of data between two devices via some form of transmission medium, such as a wire cable. The effectiveness of data communication depends upon three fundamental characteristics. The first one being delivery, deliver the data to the correct destination. Second one is accuracy, deliver the data accurately, and the third is timeliness, that is deliver data in a timely manner. Real time management transmission requires timely delivery. It is without any significant delay. In the figure 1.1 you see 5 components of data communication. Message, that is data to be communicated. We have sender and receiver. Medium, it is transmission medium, is the physical path by which a message travels from sender to receiver. You can see in the diagram. The transmedium can be a twisted pair, a coaxial cable, fiber optics cable or radio waves. Protocols are set of rules that govern the data communication. Figure 1.2 is a simplex form. Here data representations are in text, that is bits called as codes. ASCII has got 7 bits and extended ASCII has got 8 bits. Unicode has got 16 bits used to represent different languages. ISO has got 32 bits. Numbers, images, that is pixels, size of pixels depends upon resolution, audio and video. Data flow is simplex, that is unidirectional, that is it flows only in one direction from mainframe to monitor. Figure 1.3 is half duplex. Half duplex mode is each station can transmit and receive, but not at the same time. Either you can transmit or you can receive at a given time. The entire capacity of a channel is taken over by whichever of the two is transmitting at the time. .4 full duplex, also called duplex. Both stations can transmit and receive simultaneously. Signals going in either direction share the capacity of link. Link must have two lines or channel divided between signals traveling in both the directions. Network, set of devices connected by communication links. Distributed processing, task is divided among multiple computers. The network criteria depends on performance, that is transist and response time. Transist time is the amount of time required for a message to travel from one device to another. Response time is the elapsed time between an inquiry and a response. It depends upon number of users, type of transmission, medium, capabilities, hardware and efficiency of the software. All three are correlated to each other. Second is reliability, measured by the frequency of failure, the time it takes a link to recover from a failure, and the network robustness in catastrophe. Security, protecting data from unauthorized access, it is a very important factor. Here you can see a physical connection, point to point, provides a dedicated link between two devices. Entire capacity of the link is used. In figure 1.6, multi-point connection, also known as a multi-drop. More than two specific devices share a link. Single specially shared means several devices can use the link simultaneously, one after the other they come and they use the link. Time shares, users must take turn. According to your time you will get the 1.7 categories of topology, that is the physical topology, how you will lay down the network. Refers to the way in which a network is laid out physically. Two or more devices connected to a link. Two or more links form a topology. Topology of a network is geometric representation of a relationship of all links and linking devices nodes to one another. 1.8 fully connected mesh topology. Here you can see all the computers are connected to each other. Each device has a dedicated point-to-point link to each other device. Dedicated means the link carries traffic only between the two devices it connected. Advantages: guaranteed load, robust, privacy or security, fault identification and fault isolation is easier. Disadvantages: amount of cabling, input output port, installation is difficult, more wiring with respect to space and expensive hardware used at backbone mostly. Star topology 1.9. Here you can see a central device called hub, which is connecting all the systems. Each device has a dedicated point-to-point link only to a central controller, that is called hub. No direct connection or traffic. Advantage: less expensive, one link and one I/O port, easy to install, reconfigure, less cabling, but more than bus or ring. Node failure will not affect others. Fault identification is easier. Disadvantage: single point of failure. If the hub goes down, all the system goes down. Bus topology, multi-point, one cable acts as backbone to link all the devices. You see there is only one cable. Drop line, a connection running between the device and the main cable. Tap, a connector that either splices into the main cable or punches the sheathing of the cable to create a connect with the metallic core. Signal degrades due to energy transformed into heat, so there is a limitation of number of taps used. Advantage: easy to install, less cabling. Disadvantage: limit on number of taps and distances between taps. Difficult to identify fault. Signal degradation, modification is difficult. 1.11 ring topology. Each device has a dedicated point-to-point connection only with two devices on the either side. You can see it in the diagram also. Each device incorporates a repeater. When a device receives a signal intended from another device, its repeater generates and the bits and passes them along. Advantage: easy to install, fault isolation is easier, signal circulates at all time, alarm alerts the problem and its location. Disadvantage: unilateral traffic in a single ring, simple ring, break in the ring can disable entire network. Some systems have dual ring or switch cables of closing of the. Then we have got categories of network. We have got the different categories: LAN, that is local area network; MAN, metropolitan area network; and WAN, that is wide area network. Depends on size, ownership, distance it covers and physical architecture. You can see a LAN, figure 1.13, privately owned, links devices in a single office, building or campus, limited to few kilometers, sharing of resources such as hardware or data, use a single transmission media. Topology can be either a ring, bus or a star. You see a LAN, it is continued. There are 4 other LANs being connected to make a bigger network. MAN, extended over a city, owned and operated by a private company, service provider, public company. You see different types of networks, they are connected to a MAN. WAN provides long transmission of data, voice, image and video information over large geographic area that may comprise a country, a continent or even the world. WAN that is wholly owned and used by a single company is often referred to as an enterprise network. Just today we see the cable network on this aspect. Then we have got the internet, that is brief history. It started in 1967, that is ARPA, Advanced Research Project Agencies. ARPANET 1969, Network Control Protocol, NCP. In 73, Transmission Protocol came, that is TCP. It was further divided to TCP and IP, that is Internet Protocol. Internet today national service providers, NSPs, backbone network maintained by specialized companies, NAP network access points, switching stations that provide connectivity between the end users and backbone networks, regional and local internet service providers, ISP. This is the internet which we have today, though it is changing very rapidly day by day. Hope you enjoyed the session. Thank you very much.